Welcome to Happy Path Programming. I'm Bruce Eckel.
I'm James Ward.
You had an observation that you wanted to
You want to start there?
with. Yeah,
Okay.
sure, why not?
Okay, so this was something I tweeted this week where I said, developer experience is often terrible because we'd rather solve hard technical problems than solve hard user experience problems. Somebody pointed out this is actually true for easy user experience problems. And then Brian Getz had a good follow-up that I think said it better than I did. He said, you mean we'd rather solve the problems we enjoy solving rather than the ones that need solving?
It sounds so obvious when he says it.
I know. God, he's just so good.
He is. That dude is so smart.
He is so smart. So I've been thinking about developer experience a lot lately and why it's so bad.
Now, wait,
generally.
Do you mean, the way you originally said it, I would have almost said user experience is so bad because developers are solving the problems they want to solve rather than...
I think it's true for both. So if I'm a user of a developer tool, my user experience is what I'd call developer experience. If I am a user of my banking app, I would just call that a user experience.
User experience. Okay.
Yeah. So developer experience is just a subset.
So you're narrowing it down to developer tools, the experience of using developer tools.
Yeah, and maybe this is true universally with all user experience. What I care most about is developer experience and the tools that I use.
You're a developer advocate.
That's right. Well, and I'm a developer and I use these tools all day, every day.
Right.
And so I often get frustrated with the state of our tools just because I think tools, platforms, frameworks, programming languages, like everything that I use as a developer, I often get frustrated by the experience being poor. And I've been trying to think, why are the experiences poor?
Because, this is you're looking at a glass half empty, whereas I look at it and I go, man, the tools are so much better now.
Yeah.
That, I can be so much more productive because I don't have to, and admittedly, I didn't actually start using the JetBrains tools until like last December. I was just using a plain text editor and so I'm still kind of on a high from that. I was like, wow, I don't have to do all this stuff. It just tells me and gives me coaching and,
IntelliJ is an amazing tool, and I think that they really care about and focus on developer experience. I think Heroku is also kind of one of the gold standards for
cloud-based.
Yeah. So what's interesting with those examples is that there is a cultural value and focus on the experience being great. And so it certainly is possible for people to create great developer experiences. But even I don't tend towards wanting to solve those problems. I naturally tend towards wanting to solve hard technical problems. And so I was thinking about it for myself. Why don't I create good developer experiences in the things that I build?
I have an answer for that, because you're too smart.
Well, so let's say you're at a company.
Let me explain that. Because the reason that I create a lot of tooling for my own things, because I discover that if I have to do something more than once, or if it looks like, there's a duplication involved, I might as well just stop and develop a tool to do that, because I'm going to mess it up if I do it by hand. And then what I've discovered over time is that when I go back to a project, if I haven't laid things out nicely, I'm going to have to spend a lot of time figuring out, how does this tool work? What is it supposed to do? I don't remember. I will forget it because, I've moved on. So I've started making tools that help me when I go back to them, and they, explain what's going on. There's a tool that, a library that I use in Python called Click, and it makes really nice command line utilities that, have all these different commands and documentation, that just, you type the command and it says, oh, here's what this does, and here are all the subcommands, and here's how to use it. Nice. And it's like, I have to have that because
you'll forget.
I will forget
how to use your own program.
I will forget how to use my own program because,
And so being guided or choosing something that provides a great developer experience out of the box is helpful and valuable to you?
Because I'm serving my own needs.
Right.
Right.
Yeah.
Well, and those people who are really good at Unix command line stuff, and you go, oh, I need to do this thing. Oh, I'll just type out these commands because they remember them all somehow.
Yeah.
And I don't remember
Yeah.
all those things. So
Yeah.
that's why. Anyway,
Yeah.
What was your argument?
So if you're in a company that optimizes its hiring and talent to being really smart people who are generally focused on solving really hard technical problems, I think that's very different from a company like Heroku that instead focuses its talent and its hiring on people that want to solve user problems, in their case, developer experience problems.
And we should probably point out that you used to work for Heroku, so that's why you know about it.
That's right. Yeah. Mm-hmm. Yeah. And so there just is this cultural force of valuing and hiring for that goal. And I think that the majority of people creating developer tools, they're not as interested in solving the developer experience or user experience problems. They're working with Scala and the Scala ecosystem. It became pretty like, look at SBT. SBT it's gotten better, but it is not a great developer experience. It's been a pretty painful developer experience for years and years and years. It was created by one of the smartest people I know. And I think that...
Who was it?
Mark, oh God, forgetting his last name, but Mark, right. He was one of the early TypeSafe, now Lightbend employees. He was probably even there when it was Scalable Solutions, but he's a physicist. He's like a doctorate physicist, and he created SBT. And so SBT, it's funny because it's called the simple build tool because it probably was simple to Mark.
It's not,
but it was like the most complex build tool I had ever used. But to Mark, it was probably simple. But so that's just one example where really smart people were creating the tools that not smart people like me were using and having a hard time with them.
Well, smart. That's an interesting term. It's kind of over. It's like, there's different kinds of smart.
There's different kinds of smart.
So my focus has been on how do I explain something in a way that everybody can get it. And that takes a lot of effort, and it takes a lot of focus in that direction. And I miss out on, some of the fun programming things that you can do if you're not worried about that. If you're just going, oh, I want to solve this problem and, do these things. And like when I'm solving my own problems, it really is super enjoyable to get those kinds of results.
Yeah.
So I can see the draw to that, but I can also, there's a lot of satisfaction in we have some people in the Python community who are really good at figuring out what is going to be easy for the user to use. How can we make this as simple as possible, but still powerful?
Yeah.
And I mean, those people, well, and in the Scala community, you have, who's the guy from the Far East? Bill's a big fan of him.
Okay.
I can't remember his name, but he's like, he creates these libraries that people...
Oh, like Ammonite, from Howie.
Don't think so. But anyway, there are people in the Scala community who create these libraries that everybody goes, oh, that's so clear and it's so easy to use.
Yeah.
So, and there are, I don't know, how do we create more of those people?
Yeah. Yeah.
Because they've got both the technical skills and then they also understand how to make this something that's easy to understand and use.
Well, and they value that. Yeah. And so there's a motivation for them to want to do that. Whereas I think what I was trying to say in my tweet is that I think most developers, they don't value that and they don't want that. They would much rather, they value solving the hard technical problems much more.
Well, because of the buzz. It's like playing a video game or whatever when you level up, I guess, because I don't. I keep looking for a game that I want to play. And then it releases endorphins. So what they're all really after is the endorphin release. And they don't maybe realize that by creating a tool that everybody loves, you get a lot of that over time rather than the immediate, oh, I've solved this problem.
Yeah. Yeah. In the Python, when you say, what is it, import this or whatever in Python, it has the kind of Python manifesto thing.
Yes.
Is there something in there about developer experience or making like?
Well, it's
can run it right now and see. I feel like there's something in there that.
Let's see. The Zen. Okay, so this is Tim Peters.
Zen of Python, yeah.
Somebody I know from the community. Beautiful is better than ugly. Explicit is better than implicit. Simple is better than complex. Complex is better than complicated. Flat is better than nested. Sparse is better than dense. Readability counts. I guess that would be part of it. Special cases aren't special enough to break the rules. Although practicality beats purity, errors should never pass silently.
Like that one.
I guess, although what we've been talking about, with, the monadic chains, they do pass silently until the end. But anyway, unless explicitly silenced. Okay, right. I guess that solves that. In the face of ambiguity, refuse the temptation to guess. I like that. There should be one and preferably only one obvious way to do it. Although that way may not be obvious at first unless you're Dutch. He's making a reference to Guido van Rossum, who's Dutch.
Yeah.
Now is better than never, although never is often better than right now. See, Tim is brilliant.
Yeah.
If the implementation is hard to explain, it's a bad idea. We're out to it. If the implementation is easy to explain, it may be a good idea.
Maybe. Yeah.
Namespaces are one honking great idea. Let's do more of those.
Huh. I love that. I love that the Zen of Python kind of sets the foundation for what's valued in the Python community. And I think that those things create a culture. The Zen of Python creates a culture that values making things easy. And you can see by the trajectory of Python's growth, I think it's working.
Yeah. Yeah. Well, and that doesn't see, I would say that sums up more the technical pillar of the community, but then there's at least one other pillar, which is how do we treat people?
Yeah.
And Guido has always been like, be nice. The person who's asking this question might be 13.
Yeah.
And it really puts, just that one phrase, which stuck in my head, really puts it in perspective. You wouldn't abuse a child. And so assume whoever you're talking to and you're trying to answer their question. Anyway, he's, instilled that in the culture from the beginning.
Yeah.
And he also, because I just finished the Atomic Kotlin like last week. It's up on LeanPub now. And
yeah, that's exciting.
It is. It's like, it feels like an accomplishment, and I feel like it's good work. But I was talking about Python, and I said that as kind of putting everything into perspective, why would you choose Kotlin? And so let's look at these historic languages. And I think the first sentence was that Guido he had this vision of programming for everyone.
Yep.
And that kind of fits with it.
Yeah.
And that's one of the reasons
it's interesting to think about the Zen of Python as being I would say, developer experience manifesto or cultural values of the Python community. But then there is also the other side around how do we treat each other. And it's cool. You, I'm sure, need both to have a healthy culture.
Yeah. Yeah.
But I think that the Zen of Python is such a great summary of great developer experience.
Right. And you look at this and you go, well, if I follow this, I'm going to write code that people can read.
Yep.
And that makes sense to them. And yeah.
What's interesting is that I think this is very different from a Zen of something else that may be more do the most efficient thing possible, or like you could have a manifesto like this that is not at all focused on the developer experience. Sure. And so that's, I think, what I'm what I think is unique and interesting about the Python community is how they have focused so much on the developer experience, and most people love it, and it's growing like crazy.
Yeah, it's the language that taught me to not worry about efficiency,
Yeah.
because I came from, I mean, like one of the first projects that I did was I wrote in assembly language a floating point math library for this box, this multimeter, and so I was, thinking very low level efficiency from doing that. And it took me until I started working with Python, because I would go, oh, I could write the code this way, but that wouldn't be efficient. So I'll do it this other way. And then I discovered the more complicated, messy way was slower. And that if you just do it the obvious way, it's going to run fine.
Huh.
And if it's not running fine, then you investigate that. Use a
Mm-hmm.
profiler and find out where it's the bottleneck it is, which is never where you think it is.
Yep.
I would say I'm going to stand by that. It's never where you think it's going to be.
Yep. Yep.
And so you're always optimizing for the wrong thing if you start prematurely optimizing. Yeah. But most of the time, no, the language will take care of you.
Yeah.
And I think that's true with a lot of languages.
So do you think in a community that doesn't necessarily value developer experience, is it worth trying to change that? Or do I just give up and because I feel like I've been on this path of I'm going to change culture. I'm going to get developers to care about the developer experiences that they create.
I don't think that's a bad thing, but I suspect your strategies may need some rethinking.
It's like, how do you change culture? So one of the strategies that I have around this was my friend Ray Sang and I, we created this principles of developer experience, which is 4 principles that help you determine if a developer experience is good or bad.
And what are those principles?
One is do the simplest thing that could possibly work. I really learned that one from you.
Which I didn't make that one up.
I know you didn't, but you're the one that instilled that value in me.
And that one's a little bit like the what is it? The Occam's razor.
Uh-huh.
Because Occam's razor is, well, people think it's the simplest way is the right way. But actually, Occam's razor just says, try the simplest way first. Because if you think about it, it's just a very basic way to approach something. Why wouldn't you try the simplest thing first? Because if it works, you don't have to try all the complicated ways.
Right.
So it's not as but you'll see this in movies and things. They go, oh, we're using Occam's razor, where the simplest way is always the right way. No, it's not. It isn't. And with that one, I went back and found the original quote, and it was, try the simplest way that could possibly work. Try that. And so it's really just a variation of Occam's razor. Anyway.
That's awesome.
Yeah.
I didn't know all the backstory on that. So I think I should start with the first one.
Mm-hmm.
I got them out of order.
Right.
Because there is a kind of natural order to the way that Ray and I define them. So the kind of starting one is respect the user's knowledge and goals. And as an example, people do a lot of evaluation of developer experience. And what I've seen often happen is that when they do an evaluation of a developer experience that they've created, what they'll do is they'll usually base it on a piece of documentation. So we'll say that, oh, the users got through this piece of documentation easily or whatever. But what that often excludes is that documentation may not actually align with what the user is actually trying to accomplish.
May not, usually doesn't.
Yeah. So as a practical example of this, we could think that a user wants to put their application into a Docker container, upload that Docker container to a website, deploy that Docker container onto a service that will run it, have a HTTP endpoint for that service. Like, we could think that that's what the user wants, but oftentimes that is not what the user wants. The user just wants to take their piece of source code that they're working on and get it running up on the internet. And that's ultimately what their goal is in this use case.
Right.
And so
Docker is one way to do that.
Exactly, right? And so it's real easy to focus our thoughts around our developer experience and our evaluation of a developer experience on the technical kind of nitty-gritty steps that are needed, when really what this first principle of developer experience says is, no, focus on what the user is actually trying to accomplish. And this is where Heroku is just amazing. It's like you just get push Heroku master, and guess what? Your application is up on the internet. It's such a wonderful developer experience.
And are they using like Docker under the covers, or what? They have some other?
They don't. They use something else, but
okay, their own stuff.
Yeah.
Okay.
Yeah. And then respecting their knowledge means that, like, I want every developer to use Unison. I think it's an amazing programming language. It's so forward thinking and all that. But that if you were to say, how do I build a REST service? And I'm like, oh, just use Unison. Like, that is not respecting your current knowledge. Your current knowledge is Kotlin and Python. And so if I want to respect your current knowledge, I need to come to you and say, okay, here's how we can accomplish your goal with what you know today. Mm-hmm. And that's not saying that we can't always help people take a step forward into something new and great. But there's another rule that intertwines.
Telling me, well, it's almost like how Java got invented. It's like, here, you guys, make this set-top box so we can sell it. They're going, we don't like C++. We're going to invent a new language instead of doing what you told us to do. That's or what you see on Stack Overflow a lot.
Yeah.
And somebody goes, I'm trying to solve this problem. Well, why don't you do it this other way that I know?
Yeah.
It's like, that doesn't help.
Yeah. It's not a either or situation, mm-hmm. because there definitely can be cases where you need to help move people forward into a different path. So it's not saying that we don't ever do that. It's just saying we need to respect where they are today.
Right. And when you, for example, go to Stack Overflow and ask a question, you're trying to solve that problem now, not whereas maybe when you're between projects, now it's time to take a step back, maybe even do a formal retrospective and see what worked and what didn't, and say, how can we do this better next time? Yeah. Maybe that's changing to a language that knows about versioning intrinsically, like Unison does.
Yeah. Yeah.
So, which I think eventually other languages will start
adopt,
doing.
I'm sure.
Yeah. Yeah. So that's
really the first principle.
The first one.
Then do the simplest thing that could possibly work. That's the second one.
Okay.
And the third one is
try the simplest thing.
Try the simplest thing that could possibly work.
Yeah.
The third one is learning should be incremental. So we very often in our developer experiences don't help people take the next step and know what the next step is. And so that's what it pairs with, do the simplest thing or try the simplest thing that could possibly work, because we do want to start simple, but often the things that we're trying to accomplish are not simple.
Sure.
And so how do we get from that simplest thing to the next level, and then to the next level, and then to the next level? And so it's just highlighting that we should think about laying out a path that makes this incremental. So as an example of this, I created this thing called Cloud Run Button, which makes it so on a GitHub repo, you just click a button and it deploys that application on Google's cloud service.
There's a button
Cloud Run
on the repo?
Yeah, in the README.
Oh.
Yeah.
Oh, you just stuck in like some HTML or something?
Yeah.
Okay.
Yeah, just a button markdown tag or whatever you're using Markdown. So you just click the button and it takes that repo and deploys it on the cloud. So to me, it's the simplest thing. If your goal, going back to principle one, if your goal is to go from source code to something running on the cloud, it's the simplest thing that could possibly work. But what we explicitly do when someone clicks the button is we tell them all the steps that we're actually doing for them.
Oh, when they push the button, you list the steps.
Yeah, as they're actually happening.
Oh. That's
And so,
nice.
so
Slowly guides them into understanding the deeper
that's right.
part of it.
Oh, we're building a Docker container. Oh, we're storing that Docker container on the container registry. Oh, we're telling Cloud Run to deploy that container. So we actually tell them all the steps that we're actually going
But they
through.
don't have to figure those steps out before they can get something deployed.
Exactly.
Right.
Exactly. And so for that specific goal, we're trying to make that experience incremental and the learning of it incremental, and not make the user have to make a bunch of decisions that they may not know the answer to. So we could ask them, do you want this service to be authenticated or unauthenticated? We don't ask them that. We just make it, we just assume that if they're clicking on some random GitHub repo that they want this, that their goal is to make a public service. And so we just make it public. They can always, the repo can actually say it wants it to be private. But anyway, so we try to significantly limit the number of decisions that the user has to make in order to do that, and then help them learn about the decisions that were made for them, the steps that were taken.
And these are examples that you've created in your GitHub repos.
Anybody can put the button on there.
Anybody can put the button in.
Yeah.
But you're putting this in your examples so that they can easily.
Exactly.
Okay.
Yeah. I have buttonized all my samples.
Okay.
Now,
nice.
now Cloud Run button is actually in some ways not a great example of this, because one thing that I've been meaning to work on in Cloud Run button but haven't done yet is, great, we've deployed the application. So that accomplished one goal. But there's something that the user is going to want to do next, which is, I want to set up a continuous delivery pipeline for my application. Hey, let's say that that's their next goal. And today, Cloud Run button doesn't tell them how to get to that, how to move to that next step in what they may want to do. And so while it's incremental for like the one particular goal, it stops at a point. And so that's something I need to do is help the user learn how to take the next step. And that would make it even better on this particular principles of developer experience.
So are you thinking like a continuous delivery button in addition to the Cloud Run button?
Yeah,
okay.
Yeah, exactly.
And it would just configure that for you.
That's right. Yeah. So it would say,
that would be nice.
It would say, great, you've deployed your application. You've done it once. And now you probably want to start making changes to this application and running them through a continuous delivery pipeline. Click here to do that.
I like it.
So that would make it a much more incremental process,
especially for people learning about this thing. And like, again, it's like, oh, well, I got the thing working. I'll just work with it the way it is, rather than having to go learn this continuous delivery stuff. But if you go, no, we'll take you into it and show you how great it is. Because I find myself having to say, no, I'm going, even though it's going to take more work now, I'm going to benefit so much by doing this. But that only comes from experience.
Yeah.
So I push myself into, okay, automate everything.
Yeah.
And so if you have a button that gets you there, then you'll learn how valuable it is and you'll internalize it.
Yeah.
So that's 3.
Yep. So then the last one is, I think we say it as wasted time is a waste. And in developer experiences, they often are, if there's not a focus on the developer experience, they will just waste the developer's time for no reason whatsoever. So an example of this one is on Heroku. If you want to add a Postgres database to your application, you like click a button or whatever. You could do it in lots of ways, but you click a button, add Postgres, and it is like instantly available. Whereas on most other cloud services, when you want to add Postgres, it takes like 10 minutes for the thing to come up. And what Heroku does, because they actually really care about developer experience, what they do is they keep a pool of Postgres databases ready to go. So that as soon as somebody says, I want one, they just pull one out of this pool. And it's like, God, they actually like thought about making this a great experience.
And did the work. For saving. I mean, I could totally see how somebody would go, that's just 10 minutes. That doesn't really matter. Let's work on something else.
Yeah.
That's
so another example of this is things that fail early.
Mm-hmm.
So I was trying to deploy an application on some service, and 30 minutes after I told it to start, it failed with an error. And it's like, God, I really wish I would have like gotten that error like at the very beginning. instead of, after waiting 30 minutes for this thing to
Well, it's the whole
happen.
reason we do unit testing the way that we do, so that you make a change, instantly that it's failed. So you go, oh, it was that change that I made,
That's right.
not piled and piled of changes. And then you go, oh, something failed. So now we don't
Exactly.
know.
Yep.
Yeah, that immediate response
Yeah.
tells us so much.
Fail early.
Mm-hmm.
Don't waste the user's time with things that can be optimized through pools and caches and all that kind of stuff.
Mm-hmm.
But you have to actually value a great developer experience to invest the time to do this.
Well, more than that, you have to know what it is. You can't be someone who just says, oh, I'll just do all this stuff by hand.
Right.
Which, yeah, I mean, you really have to understand what those things are and be looking for them.
Yep.
And saying, oh, this is problematic. So I have a question that's a little different, well, significantly different, I guess, which is I keep coming across this low code, no code meme that's going around. And every article that I read about it, because I'm trying to figure out what do they mean, it's like saying, oh, this is going to be great and it's going to change everything. But they never say what it is. And it really smells like, I don't know if you remember when we had the, what did they call it? The AI revolution or something in the
Right.
90s.
Yeah.
And it turned out to be complete marketing horse manure. And it's like, this really smells like that to me, because I haven't ever seen an example of it or anything. Do you know what it means?
Yeah. Working at Salesforce, I had a lot of experience with no code and low code, and Salesforce is using that marketing terminology a lot to describe their platform.
Mm-hmm.
And so most developers, I think, are using general purpose programming languages, Python, Java, whatever, and are using libraries and frameworks to accomplish some goal. But it turns out companies have a hard time hiring skilled developers who know how to use a general purpose programming language to build a phone app or a web app or whatever they need to build. And so, the one possible solution to this problem is, let's make it much easier for people to build stuff, so that you don't have to be a 20-year programming veteran to be able to deliver something.
But haven't we been trying to do that all along? Make it much easier to build stuff? I mean, I feel like that's always been
so people have been trying to do it with general purpose programming languages.
Right.
And I think Python is an amazing example of non-veteran programmers being able to deliver things very well. I think Java, one of the reasons it's been so successful is for this reason as well. But there's been other efforts which say, okay, what if we didn't use general purpose programming languages to do this?
Mm-hmm.
What if we instead made like GUI builders? We made very limited programming languages, DSLs. Usually these are
I mean, how is this different from the idea of DSLs?
It's
domain
intertwined.
Specific languages.
Thank you. It's intertwined because there definitely can be DSLs in the low code version of this. But the idea is just to put so many guardrails on what the user can do that you really constrain the programming ability so much that it's much easier for people to learn. So, and I think Salesforce has probably been the most successful at doing this. There's a lot of people who don't come from programming backgrounds, don't do any general purpose programming, and are building web applications and mobile applications using Salesforce. And so Salesforce has a way to build stuff with no code. And then if you need more flexibility, then you can drop down to their DSL, which is called Apex. It's a Java-like programming language, but very constrained. You can't do libraries like it is kind of a database trigger language, like PL SQL almost. And so it's very constrained in what you can do. You can write web page backends and some of that kind of stuff with it too. But so it's kind of been, what's interesting is that what often happens with these low code programming environments is that people need more and more power. And so then there's just this endless like feature creep to the language where it ends up creeping towards a general purpose language. And so I think that there is certainly validity in the no code, low code, the need for it. What what I have been questioning lately is, can't we just do this, and shouldn't we just do this on top of the general purpose programming languages and create layers of usability around them so that when we need more power, we can just always drop down to that the lower level general purpose programming language.
One of my first like eye-opening experiences with Python was, I don't know, this is a long time ago, because I started using Python in 97, I think. And but I remember saying, oh, here's a problem I want to solve. I wanted to like resize a bunch of images. And I thought, well, based on past experience, this is going to take a while to figure out. And I found I think, there's an image library or something. I don't know if it's part of the standard distribution or one of the opens. Anyway, I thought, oh, well, this will help. And then I think I had the problem solved within 5 minutes, because it was like, oh, here's how you resize it. It had exactly that. So it seemed very, I mean, I could see somebody who doesn't know much about Python, who has a problem to solve, and going, oh, I wonder if this library will do it. And then they're done.
Yeah.
And that's kind of sort of what you're talking about.
Yeah. Yeah. And Python's library ecosystem enables essentially a low code experience for a lot of people, because NPM and Java are similar in that you just grab a library and write a couple lines of code and you're done.
And it's easy. Well, see, I think the key is that it's easy enough to use, because one of my first experiences with a library was using C, and here's this library that's supposed to do something. And then they said, oh, and you have to allocate some storage, and then you have to release the storage. And there was a bunch of weird, complicated low level things that I had to do. But now that, we have garbage collectors and things like that, it's just make the object, call some operations on the object. Yep. Okay, you're done.
Yeah. 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 So I think what will be interesting is, will we see people using the general purpose languages for the low code, no code experiences? This actually relates to another tweet that I had teed up to maybe talk about, where I said, so in my tweet, I said, superior tooling is often cited as a primary reason for declarative languages, and yet somehow I've never experienced superior tooling for a declarative language. Most often the tooling is abysmal. So in this context, and how it relates to the previous one, is that oftentimes
low code is a declarative approach.
No code is based on a declarative language, because you can build tooling around a declarative language. Is been one of the arguments for creating all these custom declarative languages. And so then when you want to take the escape hatch, because the UI builder around the declarative language is insufficient, then you can drop down and actually write the code. So actually get into,
you have a way to do everything that you need to do.
That's right. And so a lot of times, and is the case with Salesforce, is that you start in a UI builder that's creating declarative code for you. If you need more power, you
tweak the declarative
code. And then if you need more power, then there's usually a procedural language that you can drop down to behind that. So there is a nice escape hatch process, but where it falls, usually this falls off, is like we talked about before, is that when you reach the limits of that procedural language, you're not in a general purpose programming language. So you hit the cliff and you're stuck. And so, and then there's also a similar cliff with the declarative language side, is that when I was working at Adobe, they had a declarative language called MXML, and the idea was always, oh, we'll have all this great tooling, and you'll be able to design your UI, and it's just going to write the MXML for you, which was all great. But then it's like, okay, so then if I do need to take the escape hatch and go actually write some declarative code, what are the chances that my changes that I've made are going to allow me to go back to the UI builder and use the UI builder? And this is part
It's
of
a
this.
one-way door.
It's
Once
exactly
you leave that, you
once you
can't use the
you
UI builder
that's
anymore.
right.
That I saw in the very first UI builder that I used, which I can't remember. I mean, it was way back when Windows was getting started, and
Yeah.
somebody came up with a GUI builder for you.
Yeah.
And it was like, oh, this is awesome. I don't have to go in and figure out all these arcane Windows things because it would do it for you. But then at some point, you were done with that and you had to go in and start doing it by hand. And it was a big help.
And then
but it was just one. It was one way. You
Yeah.
could not reincorporate that.
Yeah. So there's always been this promise that declarative languages are going to allow us to build great tools. And I have seen some great tools, but there's always like that point where it just stops working.
Mm-hmm.
And so people are creating declarative languages and are using languages like YAML to do all sorts of things with the intention. Here's what I hear oftentimes is oh, we're going to be able to build such great tooling around this because it's possible, and they never do it. They never actually deliver it. I heard this for MXML. It was, oh, with MXML, we're going to be able to have round trip tooling.
Right. That was so they knew the problem.
They thought that they were going to be the ones, the first and only ones to actually create round trip tooling
for declarative
language, and they never did. It never shipped.
Think this problem happens again and again? What's your hypothesis?
I think in some ways it relates to the previous conversation about developer experience, because I think that I've done exactly this. I'll tell you a story. So I decided to create a workflow tool when I was at Salesforce. I don't know why, but because I want to solve hard technical problems. And so I start creating a JSON-based workflow language. Like, why did I think that I needed to create my own JSON workflow language? It got to the point where I was implementing, my workflow engine had to implement Boolean logic that was coming out of JSON and interpreting that. And so in some ways, this was just this like slippery slope of, okay, I need this, and so I need this, and so I need this. And all of a sudden I have my own programming language, basically. And so I can totally see, it's your because reasons thing. It's how did I get to where I was? Because reasons. It's like this one step at a time, solving one technical problem at a time without pulling my head up to think about the big picture and what am I really doing and what does the user actually want, led me to where I got to.
I had this experience, with build tools in general, because I've learned a bunch of build tools over time. And the initial one was Make.
Yeah. And
I used a lot. I mean, I still sometimes miss the straightforwardness and speed of Make.
Yeah.
But in particular, GNU Make, which was an extension of Make, you begin to see, because you get this little suspicion that, well, we're not really just looking at dependencies and doing things. It always seems like there's something sneaks in that's a programming problem.
Yep.
And I could see where the creators of GNU Make gave up, and it was like they realized, oh, what we need is a programming language, and we're building a build tool.
Yep.
Oh, and then they stopped.
Yep.
And you just see where they hit that wall.
Yep.
And I feel like that's happened in a bunch of places.
Build tools are a really fascinating example of this, because I think we have seen it so many times in build tools where it's like, okay, we're going to start with this declarative language, whether it's XML based. So Ant was XML based. Ant was XML based. It's been so long. But then you reach the cliff of what that created language can do, and you need more power. So what do? So what we did in the Ant world was exactly what you're describing. Is someone, I think it was James Strachan, maybe, the creator of Groovy. I think before he created Groovy, I may be getting this totally wrong, but someone created a XML-based logic language called Jelly. And so in your Ant build, you could write XML. In XML, you could say if whatever. So you could do loops. You could like, so all of a sudden we had an XML based programming language just to be able to get us a rickety bridge across the cliff that we reached with what we could do in Ant.
I knew a lot about Ant once, and yeah, it was just like, why? Because XML was cool, so we should do everything in XML.
Yeah.
You remember when
Yeah.
XML was like the next great thing?
Oh
gosh.
Yeah, and so why not build a programming language in it?
Right. And try at the time, try and say anything negative about XML, and you just got everyone jumped on you. Oh no, why would you say XML is bad?
Yeah, so build tools are fascinating because we've seen exactly this play out over and over and over again with build tools. And what's interesting about Gradle, I have issues with Gradle, but thank goodness in Gradle it's based on actual general purpose programming languages. Right. And so the tooling is actually great. So I use now Kotlin for my Gradle builds, and it is Kotlin. And so I don't have to learn a new language. IntelliJ understands my build files.
You don't have to worry about running out of gas with whatever language they've created.
Exactly. So for all of my issues with Gradle, I do really appreciate that they said, let's just use a general purpose language and forget about this whole declarative thing because we're never going to build the tools for it anyways.
My experience with Emacs when I first started using it, and then, well, this was GNU Emacs, not Gosling Emacs, and Stallman had built it on top of Lisp, and that really impressed me because it's like, oh, he started with this powerful tool that he built on top of it, and the tool wasn't going to run out of gas.
Yeah,
and it seems to me like, I mean, it always seemed to me like if you were going to create a build tool, you would want to start with the programming language and build the tool on top of that.
Yeah.
And people have tried.
Yeah.
And I mean, and I think this is going to be the same way that Java brought garbage collection and virtual machines into the mainstream. I think maybe now, people will start with build tools and go, let's build on top of a language rather than, this other approach that we've been using. So maybe it's mainstream enough now.
And I think it in the past it was hard to go this route, and it still is. Initially, it's easier to create your own language, but then you realize at some point that your language is creeping towards a general purpose language, and you are spending a lot of time as a language designer, and so I think there is this initial thing where it seems like the right way to go because it's easier at the beginning.
So that seems like a problem in general with a DSL. Anytime you go, oh, we'll have this domain specific language, how do you know? I mean, typically a DSL is created, well, I guess they have internal and external DSLs.
Right.
So like what Kotlin creates is an internal DSL. So you still have Kotlin right there if you want to use it.
So this is where Scala and Kotlin and I don't know what other examples there are, where they explicitly, one of their goals was to make it easy to build DSLs so that you can create a subset experience of the general purpose language, but you could always drop down to the general purpose language when needed. And I think
transparently without doing anything special.
That's right. It is Kotlin.
Right.
Kotlin,
so you benefit
the Kotlin from, DSL is Kotlin.
So, right. And so like you can just put it into IntelliJ and you get the benefits from it.
That's right. And so in the case of Gradle, I believe I heard that there were language changes that Kotlin made to make it easier for Gradle to have a nice build DSL. So there was a coevolution of the two, which I think ultimately produced a really nice language for defining builds,
right?
But it is just Kotlin.
Yep. Yeah. Well, that's the extension Lambda.
Yeah.
And
exactly.
And that
gets used heavily in Kotlin build in
for DSLs,
Kotlin builds. Yeah.
Yeah. Yeah. And that was like one of the very few features that they invented rather than looking at other languages and saying, oh, that's really popular and works well, we'll adopt that feature. Yeah. So that's been very helpful. So I have a I've been working the last week or so on doing some tooling to, well, one of the things I'm doing is I'm translating the old Thinking in Java fourth edition into so that it's on LeanPub.
Nice.
So it's, nicer for reading devices and things like that. And so I'm building a lot of tooling, and I always do that in Python. But one of the things that I've started to notice as kind of a strategy or a theme is what I'm sort of calling the conversion object or the conversion class. Because what I start out doing is writing a bunch of functions and functionality and just tweaking with things, and then it gets too messy. And what I have discovered is that by putting whatever I'm doing, because usually I'm trying to convert this thing, say it's a piece of code, into a piece of code which is all broken down where I understand, say, for example, oh, this is importing a package, or it's using and has definitions in it, or it just has a main in it, or it's got all these aspects. And I start out by writing functions to do that, or just writing straight code, and then it's just too messy. And then I realize, oh, what would be nice is just to do all of this stuff in the constructor. And here's the important part, is to keep all of the artifacts. And I learned this from functional programming, because, you never, one of the kind of bad idioms in Python, because it's so dynamic, is you can say foo equals this. And then the next line you go, foo equals this, which often operates on the old foo and can produce a completely different type.
Yeah.
And it's a very, shorthandy way of doing things. And it's tempting to do that because you don't always want to be making up identifiers in your head to do things.
Yeah.
But it's like, then if you want to go back and go, oh, wait a minute, what happened here? Everything's been overwritten.
Yeah.
It goes back to our old days of saving memory. So, with functional programming, you go, I make a thing and that thing never changes.
Yeah.
And if I want to transform it, I make a new thing.
Yeah.
And so what I've done in this idiom or whatever, this object converter, is that I keep all of the intermediate values. And it turns out that including the value that was passed in that I initially worked on, turns out, wow, that's really useful, because anytime I'm, say, wanting to debug it, or I discover, oh, there's this other piece of information that I want, it's all there.
Yeah.
But the object is really only the constructor and the creation of all these properties that then I can go look at and say, oh, is it so? But my main code then becomes very clear and easy to understand. I take, say, the code listing and I convert it into this thing, and then I ask questions. I go, oh, does this thing have an import? Oh, well, then I don't care about it if it doesn't. Right. And does it have a main, or does it have all these things? And I just ask it, and the code becomes really clear. And I feel like that isn't, I don't believe I've ever seen that before.
Yeah, I think in Java, the pattern for doing something similar was maybe the visitor pattern.
Oh, the visitor pattern. That one's messy, because what that's actually for is to be able to add new functionality without, so you have a hierarchy, and you want to add member functions to that hierarchy without touching the hierarchy.
Right. Yeah.
And so that doesn't, how do you see that as being the same? Explain that to me.
So I think you're thinking about it as adding methods, but I think it can also add state, right? And so what in your use case, you have some state, you have some object, and you want to add some things onto that as it gets visited or something. So maybe that's wrong. I don't know. So there's a few other thoughts that I had around this. Maybe visitor pattern is not a good analogous thing for it. So type classes are a way to maybe do something similar, where you need to convert from A to B, and so a type class can provide the conversion.
Converter automatically.
Yeah.
Yeah, I don't think this is even that complicated. This is really just a code. This isn't, I wouldn't call it, I don't know, I'd hesitate to call it a pattern. It's more of a strategy for
Yeah.
solving that problem. And it goes from a bunch of messy code, so it's pretty simple. It goes from a bunch of messy code to a much simpler, because you're looking in the constructor, you dissect and do all the
Yeah.
things and just keep making more and more properties.
Yeah.
And then once the constructor is done, all the information that you want has been automatically extracted.
Yeah.
And then you just ask that object
Yeah.
for
The
those
pieces.
properties.
Yeah.
So it's like
Yeah.
a really simple thing, but I don't think I see a lot of people doing it. And I've found it, I don't know. I guess I've been.
So in your use case, you want to keep track of kind of the steps that it's gone through.
Well,
and so that you can.
I'm following the functional practice of never throwing anything away, but making a new thing every time you do. It's like, oh, I want to know what the first line is. While I leave, I have all my lines broken up and I look at the first one and I put this in there, maybe parse it a little, and then I store that. And then as I'm going, all I'm doing in the constructor is doing this deconstruction of whatever object you've handed me, and saving all of the intermediate state in the process of doing that as properties that then I can just go say, what's up with you?
So I think the other possible pattern in functional programming, which I don't know much about and I need to learn more about it, is the applicative pattern. And I think that, so where I've seen applicative used is on validation. So if I need to, if I get an object and I want to run it through a bunch of steps, in the case of validation, I want to make some tests essentially against that thing. What an applicative will do is keep track of all of the results of those applications of different validations, and so that then at the end I can look at it and ask it, oh, did this particular validation rule give me all of the validation results back together? So
I think that's kind of similar to what I'm doing, and it isn't, this thing is, this isn't like a brilliant thing. It's just, I've discovered that it makes my code much easier to both write and use and understand.
Yeah.
So it's like, I would call it too simple to call it a pattern.
Right.
It's just, but it can be very helpful. It can be very helpful because I look at functional versus object oriented, and of course the combination of the two that we see in languages like Python and Kotlin and Scala is, and then you start going, oh, well, if I'm not in Java, which says everything must be an object, that's the only way of thinking about things, how do you decide? And what I usually find is that if I start out by writing just basic code, and then I see, oh, here's some repetition here, I'll put this into a function, or this is awkward, I'll put it into a function. And that's actually another thing I want to talk about shortly, is then sometimes I'll get to a point where I look at it and go, oh, this thing wants to be an object. It would be actually a lot easier. And the object doesn't necessarily have to do much. Like in this case, all it needs is a constructor. Usually there's a toString so that I can make sure that everything is working right. But all it needs is a constructor to solve these problems and store the information and properties, so that I take this thing, put it in this object, and then I go, hey, what's up with you? What can you do? Or, am I interested in you? So I'm just kind of like looking, because I'm not in the camp of, oh, objects are bad now, throw everything out. It's objects. Sometimes they're quite useful. It's just not all the time, which is what Java told us. That it's like, and small talk, and Java was being based on small talk.
So one thing that is also useful in this use case is if you are creating an object with constructor parameters, and then you have some things that you may interrogate or process from that constructed object. If you have a language that supports lazy evaluation, like Kotlin or Scala, I'm sure many others, then you can actually make those things lazy properties. So let's say that in your code path, you may not actually interrogate each different piece and want to actually evaluate each piece. So instead of doing it on your constructor, you do it as lazily evaluated properties, and then that can be a more efficient usage. So rather than doing it every time, all the time, you just do it as they're actually evaluated.
Right. If you start running into performance problems, you can tweak it, which is
well. And if the language makes it easy to do, then maybe you just default to making these things lazy.
Yeah, you can definitely do that kind of thing in Python, but it's not as trivial as saying
by lazy or whatever.
By lazy. Yeah. Or I mean,
it's lazy val.
It has both lazy and late initialization.
Okay.
Yeah. Whereas late initialization is really, well, actually both of them allows you to avoid making something nullable, while still late initialization is much more like that. It's like, I guarantee that before you use this, it will be initialized by some other piece of code.
Yeah.
And if you don't do it, then you get an exception that says, "Hey, you didn't. Your code is wrong. You didn't initialize this before." But then you never have to say that it's nullable, and then you don't have to do those null checks all the time. So that's nice.
That's cool.
But yeah, so how are we doing for time? Oh, wow. Okay, we should probably bring it to a close.
Yeah.
So,
well, I feel like we stayed on the happy path.
Yes.
Help people see the happy path in a new way.
That we're envisioning the happy path.
That's right.
That's what we're doing. And that's, and I think at some point we can actually, after we've done this for a while, we can talk about how we came to that name. And how it has some interesting little twists.
Our vision for the happy path.
Our vision for, we're seeking the happy path is what we're doing.
That's right.
But it also has that connotation of programmers ignoring the problems and just wanting to go down the happy path and get those little endorphin bursts and not worry about all of those problems that can happen.
Yeah.
So
great.
Well, this was fun.
Yes, it was.
Let's do it again.
Let's do it again.
Maybe in a week.
Sounds good.
Okay.